So first of all, we need to understand what is a skill list. So a skill list is an ordered collection of skill data objects. The elements of the list can be of any data type, including variables and other lists. And the special data item nil represents the empty list. Skill functions commonly return lists that you can display or process. And design database list examples are, for example, we can look up all the shapes in a design. We can, for a particular shape, look at the points in a path or a polygon. Or from a design standpoint, we could again look at all the instances in a design. Now, if you're dealing with the user interface environment, you could also locate a list of all the Virtuoso Design Environment windows which are currently open. If you're looking at a particular window, you could get a list of the pull-down menus in that window. Or if you were looking at a particular pull-down menu, you could locate the menu items in that menu in a list format. So how does a skill evaluator display a list? To display a list, the skill evaluator surrounds the elements in the list with a set of parentheses. So here we have several examples. The first line, we have a list of strings, rect, polygon, rect, and line, which would be typically types of shapes. The second example, we just have a list of numbers, each separated by a space. In the third example, we have a list of numbers, but several of the numbers are grouped into what we call sublists. So the sublist 2, 3 and the sublist 6, 7 are part of the list. In the next example, we have a list consisting of two sublists, and each sublist has a string and an integer as part of it. So you can see we can have different types of data in the same list, as is also shown by the next example. So when you see skill display a list as a return value, what you're going to see is it typically is going to split it across multiple lines. Whenever it sees a sublist, it's going to break and give you a new line. Or there's actually a global variable that's used called underscore items per line, and you can actually modify that to say print more or less items on a line. And it's mainly for display purposes. It doesn't affect the list itself. And then if you use printf or println functions to display a list, skill will display it on a single line. So that would override the default. And then here's some examples on how to set up and assign values to lists. We'll be using the single quote operator here. Later on, we'll look in a little more depth here at how to use different functions to create lists, but the single quote creates a list of the values passed into it. So the first example here is just a list containing 3 items. We can have a longer list, meaning we can have many items. Or as part of creating the list, we can also create sublists as part of that initial list. In the last one called a nested list. Here we'll look at creating new lists. So there's several ways to build a list of elements. Two of the more straightforward ways are to do the following. The first is to specify all the elements literally, meaning they don't have to be evaluated. And when they don't have to be evaluated, we would use the single quote operator to create the list. So here we have several examples. The first expression is single quote parent 1, 2, 3. That creates the list 1, 2, 3. Single quote string 1 number 1 creates that list, and then single quote 1, 1, 2, 2 with both string and numeric values as sublists. So you can see here the single quote takes everything we specified literally, does not need to evaluate anything because they're all basically low-level elements. They're not variables. Now, in the second case, we're going to actually use the list function, and it will be able to evaluate the values to create the list. So it can both evaluate expressions and look up function or look up variable names, or actually even execute additional functions. So when you need to do evaluation of the inputs to creating the list, then you need to use the list function and not the single quote. So in the example here, we set a to the value 1 and then b to the value 2, and then we call the list function and pass in a, b, and 3. The result is a list 1, 2, 3 where it looks up the values for a and b. And the last example, we're going to also use a and b again, so it will look up the values, but we're also going to do is create two equations, one for the first value and one for the second. And you can say it not only looks up a and b, but executes the equation, in this case of a squared plus b squared for the first value, and the second one a squared minus b squared for the second value. Another typical task that you will be doing in your skill programs is to add elements to an existing list. So here's two different ways to do that. The first here is to use the cons function, and that will add an element to the front of an existing list. So in the example here, we have result equals single quote 2, 3 to create the list, and then we say result equals cons 1 result. So we'll take result, which is the list 2, 3, and we will add 1 to the front of that list, and you can see the result. So the next case here is to use the append function, and the append will actually merge two lists together. So in the example here, we have two lists defined. The first is called one list with the values 4, 5, and 6. The second is called a list with the values 1, 2, and 3. And then we call the append function, and it takes the lists in the order we specify and merges them together. So one list goes first, that's the values 4, 5, 6, and a list goes second. And the net result is a merged list containing the values 4, 5, 6, followed by the values 1, 2, 3. And that is assigned to the new list called B list. Here are some points of confusion that we want to hopefully clarify. So sometimes when people look at nil, cons, append, they think initially sometimes they violate common sense. So what we want to do is look at a couple of frequently asked questions, answer them, and then hopefully clarify some of the nuances here with these commands. So the first is, what is the difference between nil and the list containing nil? So nil is a list containing nothing. It's the empty list. Its length is 0. However, we can create a list with nil in it. And this builds a list containing the single element nil. And in fact, if we check it, the length is 1. The next question is how can I add an element to the end of a list? Cons will place an element on the front, but what if we want to place it at the end? So we can use the append function and list functions together. So first of all, we just create a list 1, 2, and then we call append. We put a list first, and then we could just put the number 3 after a list, or we could try, but we will get an error because append expects 2 lists as input. So because 3 it is not a list, we can actually call the list function with 3 passed in, and it will return to us a list containing the value 3. And then our append will work just as we expect it and will result in the list 1, 2, 3. The next question here is, can I reverse the order of the arguments to the cons function? Will the results be the same? So the answer here is you're either going to get different results, which we'll look at, or potentially an error. So in the first case, we pass into cons the list 1, 2 and the list 3, 4. And you see cons keeps the list 1, 2 as a sublist in the resulting list. In the second example, we reverse the order and we put the list 3, 4 first and the list 1, 2 second. Again, it creates the list, keeping, in this case, the sublist 3,4 intact. In the third case here, we're passing in to the cons function the number 3 and the list 1, 2. And cons handles this properly and places 3 on the front of the list 1, 2. Now in this case, if we reverse the order of the list and we put the list 1, 2 first and have 3 as the second argument, it will in fact give an error because it is expecting to have a list as the second argument. Now we could fix this the same way we fixed it in the previous question, and instead of passing 3 in, we could say list parent 3 parent and convert 3 into a list for the cons function. Finally, what is the difference between cons and append? So one way to look at this is to pass in the same arguments to each function and see the different results. So in the first case, for cons, we're passing in the list 1, 2 and the list 3, 4, and you can see it keeps the list 1, 2 as a sublist in the result. It does not merge them. In the second case, append, taking in the same two lists, will result in a merged list where 1, 2, 3, and 4 are merged into a single list with no sublist. Working with existing lists. Below is a table that shows a variety of tasks that you may want to perform on lists, the function you would use to perform that task, an example of how to use that task, and then the return result of that function. So first of all, we want to retrieve the first element of a list. We use the function char. We use the numbers list here consisting of 1, 2, and 3. We then specify char and input the list numbers, and it out of the list 1, 2, 3 it selects the first element. So char selects the first. Next we want to retrieve the tail of the list. To do this we would use the cdr function. Here in the example, we're going to use cdr and pass in the list numbers. It will then return to us the list 2, 3. So it returns the rest of the list after the first element. Next, we want to take a look at how would we retrieve an element if we know the location in the list. In other words, we know the index of that particular item in the list. So one function we can use here is called nth. In the example here, we say nth, we pass in the list numbers as the second argument, and as the first argument we pass in the index. Now it's a 0 index, indicating that the first position in the list is position 0, then 1, then 2. So at position 1 is actually stored the number 2. And that is what is returned from nth. There's also a function called nth elem, which has a 1 index scheme that you can use. So there's nth or nth elem. Now the next function we want to look at will be able to tell us if a given data object is in a list. This is handy to look down a list and locate a particular thing that you're looking for. So that function is called member. So we're checking to see if something is a member of a list. So in this example, what we'll be doing here is we'll be using the function member, passing in as the second argument the list numbers, and then as the first argument the thing we're looking for in that list. So in the first example we're saying member for numbers, so we're looking for 4 in the list numbers and it does not exist, so it returns nil. In the second example we're looking for the number 2 in the list numbers. It in fact exists, and what it returns to us is the remainder of the list starting with the number 2 that it found. So in this case, rather than just the number, it returns to us the number 2 and everything after it in the list. Next, we might want to look at how we count the elements in a list. This is handy a lot of times just to see how many things we've collected. To do that, we use the length function. In the example here, we pass numbers into length and it returns 3 because there's 3 elements in the list. Next, we want to look at how we might retrieve the last element in the list. Recall, car got the first element, last returns the last one. So in this particular case, we have the function last. We're passing in the list numbers, and it returns the number 3 in a list as the last element. Notice, car returns a single element, last returns a list. The next one we want to look at here is how we might reverse the order of a list. So in this case, we could use the reverse function, and we pass in the list numbers in the example to the reverse function, and it takes the list 1, 2, 3, and in fact returns the list 3, 2, 1. Finally, we'll look at how to apply a filter to a list. This is a very powerful function. In essence, it's a loop in the sense that it goes through every item in the list and applies a test to it. So the function is called setOf, and in the example here you can see in setOf we have 3 main inputs to it. The first is a variable, which you can consider a local variable. What it will do then is look at the following argument, which is the list, and assign the value x the first time through the value, for example here, 1. It will then go to the third argument, which is the function which tests that value, and test it. So odd px is a built-in function that determines whether a input number is either odd or even. In this case, if it's odd, it returns true. If it's not odd or even, it would return nil. So what it does then is setOf says, okay, go through this entire list, each time through, assign x a value from that list and test it. And based on that test, either keep the value, which in this case, it keeps the number 1 and the number 3 because they're both odd numbers, and it discards the numbers 2 and 4 because they're even numbers. So again, this is a very powerful function, and many times in skill you're going to be using functions like this because you're going to get a list of a large amount of data and you want to filter out particular elements in that data. For example, let's say you got a list of cell names and you wanted to locate particular cell names out of that list. You would then pass in the very large cell name list, apply a test, a function, either a built-in or one that you write, or even a more complex function with, say, ands and ors in it to locate a particular cell name to then process further. So again, it's very useful for filtering out specific information that you're looking for. This demo shows examples of working with skill lists. Traversing a list with the car encoder function. So when you're working with lists, a lot of times you'll encounter a list that you haven't seen before, but that you can look at and very quickly visually understand what you want to locate. So one way to approach this is if you're having trouble figuring out the correct car and CDR combinations to get to a particular data item, you can draw the tree that's shown on the left here, where basically the tree is shown as a list containing a sublist. And then once you draw that tree to represent the list, every left branch is a car function and every right branch is a CDR function. So first of all, let's take an example list called A list, which is the list 1, 2, 3, where 2 and 3 is a sublist. Then let's go ahead and specify car of A list. That's the easy one. It pulls off the first item, and you can see we've taken the left branch. Next, let's do CDR of a list. You can see here we've pulled off the first item and we've got a list containing the list 2, 3. So it's a list with a sublist. Now one thing you'll note is we have the car function, and then inside that we have the CDR function passing in a list. We can abbreviate that in step 4a by putting CADR. This is the same as the above step 4, where we do the coder first, the CDR first to get the tail of the list, and then do the car to get the head of the list. You'll see here we've pulled the list 2, 3 out of the outer list. And now if our next item here is to go ahead and get the number 2. So in the next step here, we're going to look at how we extract the number 2. You can see, first of all, we'll take the coder of a list, and then the car of that, and finally the car of that. And so if you look at the tree, you'll see the first coder gets us the list 2, 3 within the outer list. The second car gets us just the list, and then finally the last car gets us the actual number 2. And you see in 5a the actual abbreviation of that, which is CAADR of a list. Then in step 6, what we're looking at is how do we get the number 3? Well, first of all, we have to take the tail of the list to get the list containing the list 2, 3. Then we take the car of that to just get the list 2, 3. Then we take the coder of that, which gets just the list containing 3. And finally, to get 3, we need to do one more car. So in the tree, you can see that we would do the coder, the car, the coder, and the car. And that combination will get you down to the number 3. Now in the step 6a here, you see the abbreviation of that is as CADADR. And you can see that each D and each A constitutes a single function. And in the tree again, if we step down, we do the coder, the car, and the car. And finally, if we decided to look for the end of the list, we would do a coder, a CDR, which will get the tail of the list 2, 3, and then one more CDR gets us the final nil, which is the empty list. Here we'll look at what we can do with lists as far as storing data in our environment. One of the very typical types of data that we store in the environment is a two-dimensional point. And within Skill, we represent a two-dimensional point as a two-element list. Here we're also introducing the binary operator, which builds a point, a single point, an XY point, from an X value and a Y value. So here, for example, you see we've set X value equal to 300, Y value equal to 400, and then we're defining a point P in which we specify X value colon Y value, and you see it builds the list for us of 300, 400. So again, this colon operator is actually building a list for us, and it's just basically more of a shorthand syntax to make it easier to write and read our code. Now, two other functions you might be interested in are xcoord and ycoord. These allow you to extract out the x coordinate from a list and the y coordinate. Now they're basically underneath just doing a car and a CADR to pull out the values, but again, it's more for readability and writability that we're introducing these functions. So here, for example, we have a point P equals 300 colon 400, just as an example of how we might specify a single point. Now once we have single points, maybe we want to do operations on them. So we can combine the colon operator with arithmetic operators. Now the colon has a lower precedence than, say, the plus or the times operator. So in this example here, we can say 3 plus 4 times 5 colon, and then the second part, which is 4 plus 7 times 8. So both the expressions will be evaluated and then used to create the x and the y coordinates. So 2360 is the result. So knowing that, and also combining the fact that we can use the x-coord and y-coord functions to extract particular points, we can also compute a point from another point. So here we're going to compute the point Q as equal to x-coord of P plus some delta x colon y-coord of P plus some delta y. So you can see here we're taking P and we're locating Q by adding an x and a y to it to get the new values of Q. As an extension of the point concept, we'll next look at bounding boxes. So bounding boxes are composed of a set of a lower left corner and an upper right corner. So the first element in the list is the lower left, the second is the upper right. Here you can see a box where we have the lower left specified as 300 colon 400 and the upper right specified as 500 colon 450. Okay, so here we see that we can specify a box in a list as two sublists. The first is the lower left coordinate, 300, 400, and the second is the upper right coordinate, 500, 450. Now once we've created lists, one of the things we will want to do is retrieve elements out of a list from bounding boxes. So there are some built-in functions called lower left and upper right that allow you to do this. You can see here in the example, lower left of B box, which is a list containing the lower left and upper right corners of the B box, returns the lower left corner 300, 400. Upper right B box returns the upper right corner of B box. Now you can use x-coord and y-coord in conjunction with lower left and upper right to make a very straightforward skill command here to extract, for in this case, for example, the lower, first of all, the lower left corner of B box, and then the x-coord of the lower left. So you can see the nested functions here result in extracting the x-coordinate of the lower left, which is 300, and the following one extracts the y-coordinate of the upper right corner of the B box, which in this case is 450. So using these built-in functions of lower left, upper right, and x-coord and y-coord, you can see we can very easily write functions to extract out elements of a bounding box for a particular data object. One thing to note, these underneath are simply char and cadr functions, and they assume the order of the elements is correct. So if you created in skill some sort of a bounding box where the lower left was not the first sublist and the upper right was not the second sublist, maybe they were reversed or there were more points, it would not, these functions would not give an error. They would simply extract what they found, unless you didn't have enough say points in a B box, for example, then it will give you an error. So it's important to know that, but again, they do help you write more readable code and also allow you to read and debug code more easily when you use these functions. The alternatives are, of course, to use char and cadr.
In this subsection, we'll cover several bounding box lecture exercises.
Next, we'll look at a couple of lecture exercises that will illustrate some of the techniques for manipulating bounding boxes. So the first thing we'll do is look at how we offset a box, or basically compute coordinates to move it to a new location. In the second one, what we'll look at is how we find the smallest bounding box enclosing two boxes. So what box would enclose them? And finally, we'll look at locating the intersection of two bounding boxes, or the area where they overlap. In the first example here, we'll look at how we offset a bounding box. So in this case, we'll have the variable A, which is a box which contains a lower left bounding box. and then we'll have the upper right bounding box be the new one that we're going to compute based on the coordinates of A. And so what we'll do is basically use the following template here as a starting point for writing an expression. And what we'll do is we'll compute the new box LL and the new box UR. So we'll take the A box as input, extract its coordinates, add dx and dy to it, and then compute the new values, which we'll use in the final function there called list to create our new bounding box.
So here's the example solution for offsetting a bounding box. In the first 2 lines of code here, you can see the comments. They explain that we're going to retrieve the lower left corner x and y from bounding box A, and then also add dx and dy to each of those coordinates. And in the second block of code here, you'll see that we're going to retrieve the upper right corner x and y coordinates from bounding box A and also add dx and dy to those coordinates. And then finally, we'll create the new bounding box B by specifying the newly computed coordinates for the lower left x and y and the upper right x and y.
The next example here, we'll try to find the smallest bounding box enclosing two boxes. So here we have boxes A and B. And what we're going to then do is find the box which encloses them. And so what we'll do is basically extract coordinates again, this time from A and from B. And for example, we'll extract the x coordinate of the lower left corner of both A and B. And then we'll use the min function to determine which one is less than the other one. And the one that's less will actually be the lower left corner of our new box. And the min function can take in multiple values and then returns the minimum one of that list. Now for the max, for the upper right corner, we'll use the max function. And there we'll take the upper right corner of A and B and in essence grab, in this case, the B corner of the upper right corner, and that will be our new upper right corner. So again, min and max are built-in functions that allow us to select from a list of values either the minimum value from that list or the maximum value. And that will allow us to compute or extract and then build a new list containing the minimum of A and the maximum of B to get this enclosing bounding box.
Here's the example solution to find the smallest bounding box enclosing two bounding boxes. So on the left here, you can see that in the first 4 lines of code, we're getting the lower left x coordinates for A and B and the lower left y coordinates for A and B. We're using the lower left function, and then the result of that is passed to the x-coord function in the first 2 lines, and then it's passed to the y-coord function in the next 2 lines. So we have our lower left x and y coordinates for each box, and then in the next block of code, we're going to get our upper right x and y coordinates, in this case using the upper right function. And finally, we're going to compute here the lower left and upper right coordinates of the enclosing bounding box. And to do that, we use the min and the max function. So for the lower left coordinates, we want the minimum, and we pass in to min, for example, the lower left ax and the lower left bx, and it will return to us the minimum of those 2 coordinates. So that way we'll be getting the farthest lower left coordinate for both x and y. And then for the upper right coordinate, we use the max. So again, we'll pass in, for example, the upper right x coordinates for A and B, and then it will return the maximum or largest value. And then finally, with those 2 resulting coordinates, box LL and box UR, we can create our new smallest B box coordinate list there in the final line.
Next, we'll look at finding the intersection of two bounding boxes. And here we're going to write a set of skill expressions to extract, and then finally one to describe the overlap between the two boxes A and B. So here you can see the intersection is shown in the diagram, and the template we're going to use again is very similar to the one we used on the previous page, where we're going to call the max function this time to locate the lower left corner. So we look at A and B's lower left corner, get the coordinates for that, and this time grab the maximum one, or the larger one. And similarly for the upper right corner, we're going to do the same thing. We're going to grab A and B, we're going to look at their upper right corners and grab the minimum values there, and that would be the upper right corner of our resulting intersection box.
Here is the example solution for finding the intersection of two bounding boxes. In the first section, we'll find the lower left x and y coordinates from both A and B. So it's very similar to the prior solution. We'll be extracting the lower left x coords and the lower left y coords for both A and B. And the next block of code, we'll be doing the same for the upper right. So in the second block of code, we use the upper right function, and then we pass that to the x and y chord functions for A and B. And then finally, this is basically the reverse of the prior solution. For the lower left corner, we call the max function. So it'll return to us the greater of the two values that we pass in. So we get the maximum x and y coordinates for the lower left. And then for the upper right box UR, we get the minimum or the smallest values for both x and y. And that becomes our resulting intersection box. And you can see that here we create that intersection box in the last line of code by passing it the lower left corner and the upper right to the list function. And one note here is both the min and the max functions can accept more than two values. So if you had several boxes or several coordinates, you could pass more than two in, and the min or the max would return the minimum of that of those choices that it had.
This slide summarizes the combinations of car and coulter functions that you can use to extract the lower left, upper right. So you can either use the built-in functions of x chord, lower left, y chord, upper right type functions, or if you are interested, you can also use car and catter, which is documented here in this chart. Part of the reason we provide this is, well, if you're writing your own code, you'll probably use the built-in functions like x chord, y chord, etc. But you may end up maintaining code that does not use those functions and uses the car and CDR combinations as we've noted here. So in summary, what we covered in this module was to look at the fact that skill lists can contain any type of skill data and that nil is the empty list. We also discussed using the single quote operator and the list function to create lists. Single quote does not evaluate, list evaluates. Next, we looked at using the cons and append functions to build lists. Then we looked at using the length function to count the number of elements. Then we looked at how the member function can look through a list to locate an element. Then we looked at setOf, which filters a list according to a condition you provide. Next, we looked at how you represent two-dimensional points using a two-element list. And finally, we looked at how you can represent bounding boxes as two-element lists, where each element in a bounding box list is a sublist of an XY point representing the lower left and upper right corners.